Our first lesson of Unit 7 is Intro to Polynomials and adding, multiplying monomials and polynomials. So first let's define some things. So polynomials is an expression consisting of many terms. Here's some examples. So negative 5x, I know that's not many terms, but this can be called a polynomial, okay? Or it can be called a monomial. Remember mono, that's one, right here, monomial. This means that there's just one term. See how there's no plus or minus separating it? That's a monomial. That's a special name for it. And then polynomial is also that. 6, that's also a monomial because there's just one term, and it can also be called a polynomial. Now this can't be called a monomial because there's two terms. You see how it's separated by that minus sign? This is one term and this is two terms. So this can only be called a polynomial. Okay, that's definitely not a monomial because there's 4 terms. So those are just some examples here. So standard form, this is really important. This must be written in alphabetical order with the highest exponent first. So in order, like this is in standard form. See how the highest exponent is 2? You write that first. This is also in standard form. 3, 2, 1, and then no x. So it has to go from alphabetical order, if we're looking at the variables, and it has to be written with highest to lowest exponent. This is called standard form. That's really important. So it says directions. Write each polynomial in standard form. So we have to write it in alphabetical order with the highest exponent first. So all of these are called polynomials because they consist of many terms. So that's the highest exponent. You see that squared, that 2? So this is going to go first. This 3x, that's going to go next because that just has an exponent of 1. There can be an imaginary 1 here, but remember we never have to write that 1. It's just there. There's 1x there, right? And then plus 1 at the end. That's your answer here in standard form. So now we're going to do 7k3, k to the third power. 3 comes first, 2 is next, so I'm going to put plus k2 minus k plus 64. We went from highest exponent to lowest exponent. So try number 3. Number 4, notice, okay, the sign in front is a negative. The 24, what sign is in front of the 24? Nothing, so that means it's a positive. A lot of people say negative 24 because of this guy, but remember that it's whatever is in front of the number here, or the variable. So it's negative n to the third power plus n plus 24. Now look at number 5. Do you see how there's different variables here? There's a's and b's. So remember, our standard form needs to be written in alphabetical order with the highest exponent first. So if we're looking, do you see how alphabetical order would be a first? A is before b, and 3 is the highest exponent. This a has just a 1, this a has a 2, and this just has a b. So we're not even going to look at that one. This is the highest exponent of a. So we're going to write a to the third power. So we have to put it in alphabetical order. The next one, well, my a squared is going to be next, 5a squared, because we're only looking at the a's right now, because a comes before b. Now we have 2ab, so this a just has a power of 1. And now we put minus 2b to the third power at the end. So this goes in alphabetical order. A3, A2, A to the 1, and then there's no a's over here, so we're just going to put this term at the end. Try number 6. Okay, so you want to put it in alphabetical order with the highest exponent first. So polynomials are classified by their degree and number of terms. So if we have a degree of 0, that's called a constant. 5 is an example of this. 6, 7, 100, negative 100, negative 1,000. Any of those are called constants. There's no variables next to it. It's just a number. When we have a degree of 1, that's linear. So 5x would be an example. Do you see how we added an x to it? But this just has a degree of 1. If we put a 1 right here, that 1 is there, but we don't need to write it, right? So that's called linear, when it's just a degree of 1. Quadratic is when there's a degree of 2. So if we look at our highest degree in this, it's a 2, so that's called a quadratic. Cubic is when the highest degree is 3, and quartic is when the highest degree is 4. Notice that the 3 comes first, but 4 is the greatest, so this is not written in standard form. We'd have to swap these, right? So 4, when the highest degree is 4, it's called a quartic. Those are just some examples. There's an infinite amount of examples of these. Number of terms talks about like how many terms are in these. So like this is 2 terms, this is 1 term, this is 2 terms. Each term is separated by a positive or negative. Okay, so a monomial is 1. Remember at the beginning I said that the numbers that are just all by itself, the variables, and the numbers like this right here is called a monomial. There's no plus or minus separating it. Binomials when there's 2 different terms. Trinomials when there's 3. And 4 or more is called a polynomial. So this has 1, 2, 3, 4. We could have wrote 5, 6, 7, 8, and so on. That's a polynomial. Okay, and also all of these are technically polynomials. We can say any of these are classified as that, but the number of terms, when we're actually saying the number of terms here, it has to be 4 or more, okay? Because this is specifically called a trinomial, and this is specifically called a binomial because there's 2, and this is specifically called a monomial. Okay, so it says directions. Classify each polynomial by the degree and number of terms. So this right here, first we're going to talk about the degree. Do you see how it's a constant? It doesn't have an x, it doesn't have any variables, it's just all by itself. That's a constant. And then we're going to look over here. There's only 1 term. There's no plus or minus separating this, so we're just going to say it's a constant monomial. Okay, number 8 is linear. Do you see how there's just an x term? That's linear. And then there's still 1 term, so it's a monomial. There's no plus or, like there's no other numbers here, it's just 1 term. Number 9, again, that's a degree of 1, so that's linear. We just have 1 variable here, linear. Okay, and how many terms are there? 2, so it's a binomial. Number 3 is a quadratic, because there is the highest degree here is 2. The highest degree is 2, so it's a quadratic. And then there's 3 terms, 1, 2, 3 terms, so that's called a trinomial. So that's how we classify polynomials. When I say classify by degree and number of terms, this is what I mean. Degree are all of these options, and number of terms are here. You can add or subtract polynomials simply by combining like terms. So if we have adding here, do you see how there's parentheses? There's no need for parentheses when we're adding, like there's nothing outside here that we need to distribute first or anything. So we can just collect like terms right away. So 2x squared minus x squared, remember that there's a 1 in front of that, is just 1x squared. 2x squared minus 1x squared is 1x squared. Okay, then we have 11x minus 5x. 11x minus 5x is 6x. Okay, and then 13 minus 23 is negative 10. Okay, now do you see how this one has a subtraction sign? This can't, like, we need to distribute this to everything behind it first, because that negative is different than a positive. Like if we were to distribute a positive 1 to everything, it wouldn't change any signs. But if we're going to distribute a negative to everything, it's going to switch all of those signs. So this stays the same. I'm just going to bring that down. And instead of a positive 7x, I have negative 7x minus 3x squared minus 1. Now I can combine like terms. So 4x squared minus 3x squared is 1x squared. 5x minus 7x is negative 2x, and then bring that minus 1 down. So number 11, notice it's a plus sign, so I don't have to distribute anything. I'm just going to collect like terms. K squared plus k squared is 2k squared. Negative 4k plus 9k, 5k. And then 7 minus 3 is 4. I want you guys to try number 12. Now notice number 13. Do you see how there's a negative sign here? We have to distribute that to every single piece. It's like a -1 there. So the first part of it is just going to come down, 3x squared plus 7x minus 1, that stays the same, but all of these signs are changing. So now it's -x squared minus 2x plus 5. And now we can combine like terms. 3x squared minus x squared is 2x squared. 7x minus 2x is 5x, and -1 plus 5 is 4. And then you guys try number 14. Okay, so to multiply a monomial and a polynomial, simply distribute the monomial to the polynomial. For exponents, recall the product rule. So remember the product rule here, when we're saying like x to some power, let's say x squared times x to the third, remember we add 2 plus 3? So it'd be like x to the 5th. So we just add, when we're multiplying two different variables, or two of the same variables, like x, and they're raised to some power, we just add those powers together. So all this is saying, to multiply, this is multiplying a monomial, this single term, to a polynomial, right here. We distribute the monomial, so we're going to distribute this into the polynomial, okay? And remember, we have to put it in standard form, which means greatest exponent to least exponent, and it has to be in alphabetical order if there's more than one variable. Okay, so x times x is x squared. X times x is x squared. X times 4 is 4x. That's it. Now, we're going to multiply 5m to the third times 3m squared. When we multiply there, we're going to say 5 times 3, which is 15. And then we're going to say m cubed times m squared. Remember, we add the exponents. Just like here, when we multiply here, we add exponents when multiplying. So 3 plus 2, that means now there's m to the 5th. Okay, now we're going to multiply 5. And what's in front of this m? A 1. So 5 times -1 is -5. And m to the third times m, well, there's a 1 here, right? So there's a 1 here. So we're going to add 3 and 1, and 3 and 1 is 4. So it's m to the 4th. And then 5 times -7 is -35. And then m to the third, because there's no m's over here to collect, so we're just going to put m to the third on the end. Okay, try 17. Now look at 18. So here we have a couple extra, like we have a p squared and a q to the third. So when we multiply in, we're gonna only combine p's with the p's, right? So p squared times p to the 5th, we're gonna add 5 and 2, so it's p to the 7th. And then we have q to the third times q squared, so we're going to add 2 and 3, so it's q to the 5th. Now here we have a minus in between, and we have p squared times p. Well, that's like a p to the 1, right? There's like a 1 here. Maybe we'll just write a 1 and a 1. So we have 2 p's over here, and we're adding it to that 1 p, so there's p to the third, and then q to the third times q is q to the 4th. Okay, and that's your answer. You guys try 19. Let's do 20. So now we're going to do two different steps. Do you see this plus 13x squared y squared minus 6? There's nothing to distribute here, so we're just going to leave those alone for now. We're going to distribute this 2y into each of these pieces. Now, first, always multiply the numbers in front, the coefficients. So 2 times 6 is 12. Can we combine x and y? No, right? One's an x, one's a y. So we're just going to put x, y right next to each other. When you're writing this, when you're multiplying like x times y, make sure to put x, y and not y, x. You always want to go in alphabetical order here. 2 times 4 is 8, and it's a -4, so it's -8. 2 times -4 is -8. Y times x squared y. So we're going to keep the x squared the same, and then we're going to multiply y and y. So y times y, well, there's a 1 on each of these, so it's y squared. 1 plus 1 is 2. And then I'm just going to bring everything else down. 13x squared y squared minus 6. okay, can I combine any of these terms? I can combine the middle. Do you see how they have the same variables? X squared, y squared, x squared, y squared. That means these are like terms and we can combine these. So I'm going to bring the 12xy down and I'm going to say negative 8 plus 13 is 5, and I keep these the same, 5x squared, y squared. Okay, you don't add exponents when you're adding like this. When you're saying negative 8 plus 13, that's a 5, and you don't add these exponents. You just keep them the same. All these exponents tell you is that these two are like terms, so we can combine the coefficients in front. Negative 8 and 13 is 5, but we're going to keep this the same. Okay, and then we're going to, so all I did here was replace this whole middle term with 5x squared, y squared. I kept the negative 6 and the 12xy the same. So that's your answer there. And we need to put it in standard form. So that's not your answer, sorry. We need to put it in standard form. Don't forget to do that. All of these are in standard form, right? X squared, x. So we put that in standard form from greatest to least. M to the 5th, m to the 4th, m to the 3rd. That's in standard form. Remember when we put it in standard form and there's more than one variable, we put it in alphabetical order. So P comes before Q, and P to the 7th is greater than P to the 3rd, so that's in standard form. Here we're going to look at the x's because x comes before y. So the greatest x we have is x squared. So we're going to put 5x squared, y squared in the beginning. And then we're going to put 12xy after it, and then minus 6 goes at the end. And that's your answer. Let's try 21. If you're multiplying here, negative 2 times, there's a 1 in front of that r cubed, so negative 2 times 1 is negative 2. And then r times r cubed, there's r to the 4th, there's 4 r's there. Now negative 2 times negative 6 is a positive 12, and then r times r squared is r to the 3rd. A negative 2 times a positive 6 is a negative 12, and then we're just going to put that r at the end because there's no r's here with that 6. Then I'm going to bring the 4r cubed down because that's just by itself, so I can just bring that down. And you see that negative right there? It's like a negative 1. We have to distribute that inside, which means all we're doing here is changing the sign. So it's going to be negative 5r to the 4th minus 10r. And now we look for the like terms. So we have a 12r to the 3rd and a 4r to the 3rd. We have a negative 2r to the 4th and a negative 5r to the 4th. And we have a negative 12r and a negative 10r. Do you see how those are like terms? So we're just looking for, okay, well, r to the 4th is similar to r to the 4th, so we can combine these two. So negative 2 minus 5 is negative 7, and we don't add the exponents because we're adding the numbers together. We just keep the exponents the same. This just tells us that it's like terms and we can combine. If we were multiplying these two numbers, then we would have to add the exponents. Okay, but since it's just negative 2 minus 5 is negative 7, we keep that r to the 4th the same. And then 12 plus 4 is 16, r to the 3rd, you keep those the same. Negative 12r minus 10r is negative 22r. Is this in standard form? Yes, because it's r to the 4th, r to the 3rd, and then r. So it's greatest to least. You guys try 22 and then show me when you're finished.